What if, in one synchronized moment, every human being on Earth pointed a laser at the moon? Billions of hands, billions of tiny beams, all converging toward that silent silver coin in the sky. Would it glow brighter? Would it shimmer red? Could we, for the briefest instant, reshape the light of the heavens with the tools in our pockets? It sounds absurd, almost poetic, like asking if enough whispers could move a mountain. But in the spirit of wonder and science, let's follow this question, not for the answer, but for the journey it takes us on. Let's start with the basics. The moon is about 384,000 kilometers away. That's roughly 30 Earths lined up, end to end. And your average laser pointer, the kind you might use in a classroom or to entertain your cat, emits around 5 milliwatts of power. Tiny, harmless. Its light is coherent, meaning it stays tight and focused, at least for a while. But space? Space is the great equalizer. Even the most disciplined beam eventually spreads, like a secret shouted into a canyon. Still, let's imagine that every person on Earth, more than 8 billion of us, has a perfectly functional laser pointer. All different colors, all tightly aimed at the moon. That's 40,000 watts, give or take. It sounds massive. But light, like the universe, is all about scale. The sun, that ever-burning celestial engine, bathes both Earth and moon with about 1,360 watts per square meter. The moon's visible disk, what we can see from Earth, is about 10 trillion square meters. That means it reflects around 10,000 terawatts of sunlight. Compared to that, our combined laser effort is like lighting a match at noon in the middle of the Sahara. You wouldn't see a difference, not even with a telescope. But let's not give up. Let's push this further. Let's upgrade. What if instead of classroom toys we gave everyone a 1-watt laser? Dangerous, yes. Capable of burning skin, blinding eyes, and igniting fires. These are not toys. These are tools of precision, and sometimes chaos. With 8 billion people each firing a 1-watt laser at the moon, we're now talking about 8 billion watts, 8 gigawatts. That's the output of several nuclear power plants combined. Impressive. With perfect synchronization, no cloud cover, and all aimed at the right lunar phase, we'd be hitting the moon with about half a lux of illumination. To put that in perspective, that's half the brightness of moonlight on Earth. So the moon wouldn't shimmer red, it wouldn't change color, it wouldn't even blink. It would just sit there, bathed in the cold indifference of the cosmos, while we on Earth strain our eyes, wondering if we did anything at all. But let's not stop there. Let's unleash imagination. What if we gave every person a searchlight, the kind mounted on helicopters, piercing the night with 50,000 lumens of brightness? Focused perfectly, those beams might begin to pierce the lunar dark. Now we're doubling the brightness of the moon's night side. That's something, still imperceptible to the naked eye from Earth, but measurable, quantifiable. A whisper turned into a murmur. Still, we crave more. So we abandon practicality and hand each person an IMAX projector, 30,000 watts of cinematic brilliance. Now the moon starts to blush, barely, like someone turned on a flashlight across a football field. The shadows dance a little differently, but only if you're really looking. And then, we break the laws of moderation. We give every human a laser the size of a Boeing 747. The Boeing YL-1, to be specific. A megawatt-class laser built to shoot missiles out of the sky. Imagine billions of them aligned with mathematical precision, pointed at the moon. Now we're not just lighting it, we're cooking it. 5 petawatts of energy slamming into a celestial body made of ancient dust and rock. For a few minutes, the moon gleams like a second sun. Its surface heats, glows, and then begins to change. Not just in color, but in state. Rock becomes plasma. The very soil lifts into space, atom by atom, as the moon defends itself the only way it can, by turning into a rocket engine. Because when you vaporize rock with that much intensity, it doesn't vanish. It moves. And every atom expelled pushes the moon ever so slightly away from us. This is called laser ablation. It's a real concept, used to power experimental spacecraft. The idea is simple. Heat a surface until it ejects material, and let the reactive force push the craft forward. Except our spacecraft is the moon. The moon, our silent guardian of tides and time, begins to move. It starts slowly, a whisper in the void. But space has no drag, no friction, only momentum. Within weeks, the moon drifts out of range. The tides on Earth begin to wobble. Nights grow darker. Ancient rhythms falter. And yet, we press on. Now we enter the realm of fantasy. We arm every human with the most powerful laser ever created, the National Ignition Facility's 500 terawatt confinement beam. Designed for nuclear fusion, it pulses for only nanoseconds, but we imagine it running constantly. A sustained scream of ultraviolet light. Except we've made a fatal mistake. These beams don't just pass through the atmosphere, they turn it into fire. The air ignites, oceans boil. The Earth, our launch pad, our cradle, is scorched in a halo of radiation and fury. Humanity is erased in the blink of a cosmic eye. And still, the moon burns. Its surface peels away in layers of incandescent gas, a sphere of plasma, glowing brighter than any star in our sky. So bright, its reflected light is thousands of times stronger than the noonday sun. It sears shadows into mountains. It blinds the night. It scars the earth that no longer watches. And then, the inevitable. The moon, now a glowing ember of what it once was, slips free of Earth's gravity, like a balloon released by careless hands. It begins a lonely journey around the sun. Its path unstable, its fate uncertain. Will it crash into Mars? Will it spiral into the sun? Or will it return? A cosmic boomerang, flung by our own arrogance. But maybe that's the lesson. That no matter how powerful we become, no matter how much light we shine outward, there are some forces in the universe that were never meant to be touched. The moon doesn't need our lasers. It has been watching us quietly for millennia, through our wars, our poetry, our dreams. It reflects our light not because it wants to, but because it can. And maybe that's enough. Maybe the miracle isn't that we could one day illuminate the moon, but that in all our smallness we still look up and try. We reach for it with questions, not conquest, with wonder, not war. And if every person on Earth, every child, every elder, every skeptic and dreamer, raised a laser toward the moon, maybe the real light isn't the one that hits the sky. Maybe it's the one that stirs in us, the one that remembers how to wonder. Before you go, if this journey sparked even a single new thought in your mind, don't let it fade. Subscribe to the channel, leave a comment sharing your favorite what if, and click the like button so this light reaches others, because sometimes one small beam can start a galaxy of questions, and that is the brightest light of all.